Now let us study optics, called geometrical optics, also called ray optics. Right? Light is considered as a wave like this, but not this big, very small. A disturbance that travels at this speed in vacuum. If you convert this to kilometer, it comes out to be this much, 2,99,792 kilometer per second. And the speed of light is represented by a letter C, that is this, value is this. If you think how much time it takes the light to travel from sun to the earth, it takes 8 minutes 20 seconds, right? It always travels in a straight line. Now, if you can think that light can go around a circular path, if you can go in a circular path, it will go around the earth 7.5 times in 1 second. Now, when I say a wave is represented like this. From this point to this point is called the wavelength lambda, represented as lambda, length of the wave. Since this is very small in case of light, so we have to use smaller units. Sorry. And the smaller unit is called angstrom. 1 angstrom, the symbol is this, is 10 to the power minus 10 meter. Our eye is sensitive to light whose wavelength varies from 4000 angstrom to 7000 angstrom. And from here to here, there are the 7 different colors: violet, indigo, blue, green, yellow, orange and red. Now, what is a ray of light? Ray of light. Light wave traveling in a medium travels from one point to another in a straight line path, That path which is represented by a line and an arrow is called a ray of light. So a ray of light is represented like this. Now, then coming back to reflection of light. When light falls on a surface, it is sent back to the same medium. This process is called reflection of light. Now, what is a mirror? A smooth and polished surface is called a mirror. And your looking glass is also a mirror, a very good mirror. Now, laws of reflection of light. Suppose from M to N, this is a plane mirror. This is the back side of the mirror. This is the front side of the mirror. To the mirror, I draw a normal. Not a perpendicular normal, because a mirror is a plane. If this is making 90 degree with the plane of the mirror, this is 90 degree, then this is called normal to this surface. So this is the mirror to its surface. This is making 90 degrees, so this is called normal. A ray of light is coming like this. This angle is called angle of incidence, and this angle is called angle of reflection. And the first law, according to the first law, this angle is equal to this angle, and this ray called incident ray, this ray called reflected ray, and this normal, they lie in one plane. So the first law is the two angles are equal, and the 3 lines, this AO, incident, reflected and the normal, they lie in one plane. Now, deviation represented as delta of light in a mirror. MN is a mirror. This is the normal. Suppose the incident ray is coming like this, AO. So this angle I represent as theta. According to the first law, the reflected ray will also make the same angle. That is, this is equal to this. So both angles are theta. Now, if this mirror MN was not there, then AO would have traveled in this direction. But because of the mirror, it is traveling in this direction. So from the original path, this has bent by this much. This whole angle is 180. So this is the amount by which it has been deviated due to the mirror. So this will be equal to 180 minus this, that is 2 theta. So the deviation in a single mirror is 180 minus 2 theta. Now instead of one mirror, if we have two inclined mirrors, then what is the deviation? Now look, MO is one mirror, ON is another mirror. They are inclined, angle between them is theta. AB is incident ray. So at this point I draw a normal BB dash. Let this is the angle of reflection, incidence. According to the first law, on the other side of the normal, on this side of the normal, the reflected ray goes like this. So this is equal to this. Again at point C, this is the normal. C dash is the normal. Let this angle is beta. According to the first law, on the other side of the normal, the reflected ray also makes the same angle. So there are two deviations, deviation here and deviation here. Deviation here is represented as delta 1. So delta 1 will be this whole angle 180 minus 2 alpha. Here the deviation is this, means from the original path this ray has deviated this much. So this delta 2 is equal to 180 minus 2 beta. So the total deviation is the sum of these two, delta 1 plus delta 2, that is this plus this, that comes out to be 360 minus 2 times alpha plus beta. Now look at the triangle BOC. Let this angle is theta. Now since this is beta and this is perpendicular to this, therefore this is 90 minus beta. To this mirror, this is normal, this is alpha. So this much is equal to 90 minus alpha. So in triangle BOC there are three angles, theta, 90 minus beta, 90 minus alpha, and the sum of three angles should be 180. So the sum of three angles should be a 180. So first angle, second angle, third angle is 180. By simplifying this, we get theta is equal to alpha plus beta. Now substitute this value of theta, that is alpha plus beta, here. Instead of alpha plus beta, I write theta. So your total deviation comes out to be 360 minus 2 theta.